Alright, let's talk about the reorder routes to make all the path lead to city 0. So you are given an city and the node from 0 to a -1. So you want to travel between two nodes, but the problem is you have to find out there's a path coming back to the city 0. And at the end, you need to return a minimum number of the edges change. Alright, let me draw the diagram. Alright, so 0 to 1 is outgoing, right? So I know 0 to 1 is outgoing, and I'm making sure this one, if this node is outgoing, I'm going to remember it and then change the direction, right? So 1 3 is outgoing, so this one is still outgoing. 2 3, this is incoming, right? And then 4 4 0, this is incoming. But I know the 4 is outgoing to another one, which is not correct, right? Should be incoming from another node, right? So basically, this is supposed to be super simple. I struggle for a bit. So here's the problem. So how do I know that when do I need to keep track? So imagine you don't look at the rate error. So look at this. If you know this is outgoing by default, we already know that this doesn't. We can think reversibly like, okay, these three arrows should be changed, and I can actually create a class to making sure this path was the original path, and this one should be the correct path, right? And then I will just reverse it later and trying to use a breadth search. So breadth search, I will traverse the first one, and then I will just go through any node which connect to the node 0, right? So I'm going to create a class. I'm going to call s, and I'm going to say env, and also the boolean. So this is going to be path. So this path is going to just put a rect down is this is the original path or not, right? So public s env boolean path, right? List of v equal to v, list of path equal to path. And I'm going to use hash map. So hash map, I'm going to store the integer which is a node, and I'm going to give a list of integer, list of text. So I'm going to just making sure how many destination I will go from node 0, or how many node I will come from other node, right? So I'm going to say map, give it a new hash map, and then I'm going to just traverse the entire fun. So net put AI, I'm going to initialize my list. Now I'm going to traverse the entire connection, and then I will say in u equal to c0, v equal to c1, and I'm going to say map.getU dot add. So it's going to be new destination, right? So from u to v, right? So the destination v should be v, and then the path should be what? The path should be true, because this is the path that is originally in the graph, right? So how do you know how about v? Map.get and new test, and then I'm gonna put u over here. And I'm gonna put false right here, because if you say 0 to 1, this is correct, but 1 to 0, this is incorrect, right? So I'm gonna put the imagined path inside my map. Alright, then I'm going to put a q and put the integer. So this is the q for what? Q for the node. Well, q dot offer 0, right? And I also need a boolean array. I'm going to call visit new boolean to making sure that I traverse the entire graph with every single node, right? And then I'm going to say while q is not empty, so I traverse the entire queue already. So in node equal to q dot pull. So I will pull 0 out, right? So I'm going to say visit at node equal to true. Alright, now I need to traverse the neighbor, right? So the neighbor is going to be what? The dash at d. So map.get node. So I will get a list of the class D class test, right? And then I'm going to just say if the visit at visit at DFV is already visit, I don't want to visit again, right? You don't want to visit something you visit already, right? And then if not, I'm going to making sure that that these DFV is actually equal to true, right? And then now I need to making sure if this path, the path we put down, the path we put down is originally in the graph. So if the path is already true, then I need to change the direction. So I have a variable called result. So result plus plus, right? And at the end, I need to return the result. So if the path is originally like true, the outgoing, right? Then I need to just making sure the result equal to true. Now I need to put the path, put the node back to the back to the queue, right? And this is pretty much it, right? So let me see if I have any question. Probably not. Let me run it. All right. So this is actually really challenging for sure. Like I get confused a lot. Like why do I have to like keep track of this? But if you draw on a paper, you probably know. So let's talk about time and space. This is going to be a space, right? And this is going to be a space, the all of n, and this is all of n. And this the value is actually depending on how many nodes you connect to the node itself. So I'm saying I'm gonna say all of n, and this is going to be time, this is going to be time, and this is going to be time. So all of n, and then this is length of the connections. So it should be shorter, right? But it doesn't matter. So I would say all of n, and this is definitely all of n because you will definitely pull from a queue, and then for every single time you will traverse like one queue probably at the same time, and then if you visit, then you just continue, you don't visit again. So this is all of n. So time and space are all of n, and this is pretty much the solution. I'll see you next time. Bye.